Will is on the research faculty of Prescott College in Arizona, and Will is one of the directors of the 5 science impact centers. The other universities, in addition to ourselves, are University of Pennsylvania and University of New Mexico. And Will is here because we want to determine the way we can collaborate. He's talked about, he has this technology and visualization techniques, and he recognizes, we had a very fruitful discussion in our seminar this morning, that he needs to place this within a process. And the process he wants to talk about is a process we're interested in, is collaborative problem solving and a joint fact-finding process. So we're hoping that that will bear fruit, and I'm sure it will bear fruit in a joint venture to come. So I'll let Will take over.
Thanks very much, Herman. I'm probably not going to stand for this whole during the whole talk, if that's all right. I'll stand up so you can get a look at me. A look at me is probably sufficient. I want to let you know there's some cheap flights that come into town here. You can see that Northwest has a special flight. You get really good rates if you come in on Northwest. The pilot is very experienced at not flying, and so that is one slide that just tears my granddaughter apart. She cannot stand it. Scares her to death. But it's one of my favorites because I wonder if this is civilization looking at events happening. A little history there. I'll let you read the fine print. We've been NASA funded, have worked with what does it take to help urban jurisdictions solve their problem agenda for about a decade now. We have worked in these various areas and had some of these projects also with BLM and some with jurisdictions with whom you have worked. I'm going to sit now so you get a clear shot of the visuals. There's no more funny stuff coming up. That ostrich was the best I had. These are places where we have done presentations or had projects in the last 5 years. So that only lets you know we travel and talk a lot. These are the issues with which we find people dealing, no matter where we go. These are probably characteristics of the issues. They cross disciplines, jurisdictional boundaries, and they're here to stay. They are not going away. We do need to resolve these. Lately, we've given a lot more attention to disaster issues. They can be commingled with terrorist events as to how you handle them technically. How you handle them from a process point of view is much different. Yeah, I would hesitate to speak to science issues here at MIT, but due to the nature of the project with USGS, we really must take a look at the science, and we're finding local jurisdictions increasingly aware of what science can offer them as they work to resolve issues. A lot of science information out there, and it's really hard to step through a lot of this and really make it relevant to a local jurisdiction dealing with what do they do with their own land preservation. Not all this is bad news. Some of this is good news. We seem to be getting more cropland production per capita. Our yields are going up. And then you might want to peel the onion of this data and ask, well, at what price are our yields going up? This is mega information. And when you get to the level of science that touches on climate change, it's really scary to people. And the results of this will really be, they will change the way civilization inhabits and uses the earth and the way parts of civilization interact with each other. This is not new news. And in today's Boston Globe. We see scientists warn Arctic is warming quick. That's been going on. We've known about this for 15 or 20 years. And we still are reluctant to take any action about it. We're probably living in a time when you who are students at least, will deal with the worst problems and challenges that civilization has ever faced. The work we do is with technology. How do we take the science, use technology, and pipeline that to decision makers? The work that you excel with here is really the process of how you do that, and then how do you resolve the conflicts that result once the different scenarios are portrayed. What I'll show you as we progress here is how we build scenarios. Let me make a couple editorial comments here. We work with decision makers who are elected or senior staff in jurisdictions. This is not the private sector. These are public sector decision makers. They differ from the science community in several different ways. Now, I'll let you fill in the blanks here. It's always wonderful to have a literate audience, and I don't have to read these things. These differences are probably to be acknowledged and celebrated rather than trying to resolve them. I don't know that we would ever really want to jam mayors together with scientists. I think what we need is a bridge, that double-edged arrow up there that helps get the information from the science community packaged and over to decision makers in such a form that it can inform their decisions. But these people don't have to change their cultural or business backgrounds in order to do that. What we do has got to be relevant, and it's got to cross disciplines. I think that's been pretty obvious. Societal questions are difficult to separate from science questions. I've done it here, but it's very arbitrary. If we look at population growth as a proxy, if you will, for a host of societal questions, we see megacities emerging. This work is done by Susan Wachter at Wharton, and it's interesting to see the U.S. configured in this way. We will deal with this in one way or another. Whether we cope wisely with this or not remains to be seen. One of the projects we're looking at is how do we, with the USGS Science Impact Project, look at these areas where population will concentrate and balance that with resource availability or hazardous areas, transportation limitations, other such things. I'm going to step through these very quickly. I just want to note that we're losing population in the middle of the U.S. and gaining it in these other areas which you see. This one is Phoenix as built today. There are 23 jurisdictions here. All of them use a comprehensive or general planning process. All of them talk to each other. None of them would build Phoenix this way given the chance to start from scratch again. No elected official, no planner, likely no citizen. Let me show you how we got this way. Using written general plans, which sets the stage for incremental change. Incremental changes that are keyed to whatever time frame, possibly as we talked this morning, the period of term of office of an elected official, board of commissioners or something. These are costly, and they build things like this. Now this is satellite imagery. Some of you have seen this before. It's so vivid that I play it again and again. This is Landsat from 73 forward. The yellow line is the urban boundary of the Phoenix metro area. The red is disappearing agricultural land. That comes up to 99. You saw that happening under your kitchen sink. Who would you call? This is Tucson. This is more accurate because this is from 1950 forward, and what you see emerging are building permits. So everything legal built in Tucson is included in color by decade here. And from a planning perspective, you can imagine the problems that emerge as you put a high residential population against a natural area. Mount Lemmon here, the bighorn sheep are gone. You need to bridge these people across the Rito Wash to population centers down here. The Santa Cruz River no longer flows unless it floods. Used to be a steamboat ran up down the Santa Cruz River. It's an impressive ditch today. But we, in our travels and the work we've done, we've never run across anyone who intended ill for their community. Really, people would like to do the right thing, by and large. They differ in what it is, how to accomplish it, the methodology, and so forth. This is kind of where we see written general plans. And this is a brief kind of interlude here where I show digital comprehensive planning, model-based planning, as really the technology which will better embrace science, bring science to the decision-making table, and produce added value for really less money. This is what we spend on written general plans today. And these are the documents by which we guide the future of the nation by the way we shape the places where we live, work, and play, be they crossroads or huge megacities. This is how, this is the process by which a written general plan is developed. We go through that process in most jurisdictions repeatedly, and it costs a fortune to do that. Maybe 5 years, maybe 10. In our case, in Yavapai County, it was 20. This is something that we really never have figured out. A lot of people have done some good academic studies on this. We don't know this, and I just pose it as an unanswered question to you. Jumping to technology, digital comprehensive planning is the model suite by which we would propose to interface science with decision makers. We have the modeling capability to do this. We are extremely weak on the process by which this occurs, or, as we've mentioned, any process to resolve conflicts that may ensue from, okay, how do we get to this particular preferred future? Written general plan does this. It'll build land use scenarios, economic scenarios. In the case of Lake Tahoe, working with Rich Bernkoff, we'll be doing environmental thresholds. These are conditions that the local community does not want to exceed. There are always placeholders that we build into the software. Tourist numbers appearing, disappearing for a weekend, a season, are simply a different land use attribute. So if you're GIS literate and you understand the attributes that go with parcels, tourists just change those attributes for that particular period of time. And you go around the loop again. The interesting thing here is your investment is in a model, and it's very easy to go in and change the variables in the model or the time frame or whatever you may wish to change, the database, the population growth rates, and generate new scenarios. And you can save those off in the lower right-hand corner here as old scenarios. Do configuration control on the one you want to save as the real one. Our digital, our comprehensive general plan has 3 model elements. We have a fourth that's seldom used but deals with sustainability. It's very simple for us to tie sustainability to land use by using the methodology of Wackernagel and Rees. Very straightforward. I've got a couple slides later on about that. The interesting thing to us is that when you take folks into the future, they start to agree. Get them out there 50 years. And their political, their religious, their cultural differences really disappear. We all want clean water, clean air, well-behaved children, well-behaved grandparents, grandparents that babysit the children, help pay some of the costs of this, that, and the other thing. Peace on earth. Very few of us want to fight. there's some interesting academic literature that says we're genetically inclined to warfare. But all the people we talk with really share common values when you get out far enough into the future. Therein lies the value of being able to construct a model that takes people into the future. Also therein lies the problem and the challenge of what is the process by which you get to this future of peace and harmony, quiet and clean environment. And that's where I think we have an excellent opportunity for collaboration. We do not resolve the conflicts and roadblocks along the way. But the future is a magic place to go. And when we model into the future, we just sidestep all the current problem agenda that folks have. And once they agree on a common future, then it's easier for them to back up and look at the concrete steps that take them there. I don't talk about every slide that long, thank heavens. A spatial growth model simply builds maps of the future. It has characteristics that we can model any size. It's scalable geographically. We can do sub-area modeling, and any area within a model can be treated differently. So it has endless land use categories that include water use. To build a spatial growth model, and this is the heart of the technical process, you've got to tell it what land it can develop. What's up for grabs here? That's a value judgment. Then you've got to tell it by what rules can it develop that land. Where can you put multifamily, single family? Where does open space go? Where does commercial residential go? What goes for new roads? And you weight those priorities for that land as it's being developed. You need to know how your population is arriving, how many people are in multifamily, single family situations and so forth, and you need to time step. This is the heart then of a spatial growth model. And really, if you deal with any of the other 20-some spatial growth models that are out there, these are the conditions that, that must prevail. We've designed ours to run in Esri-compatible format, in standard GIS programs, and be very, almost embarrassingly simple to run. This is a population projection for how people arrive. It's the kind of data necessary to support building a model. It's the kind of information the public never wants to see, unless you get someone that is quizzical and curious about where'd you get that. You always need to have that underneath that. But running those rules on Tucson, you can see growth by decade. Here's 2010, 2020. It's just a standard sprawl rule set in that one. This is what we get from that run. And we can run that at the regional level, and you'll see this running from 1991 to 2050, projecting population growth basically around existing transportation corridors. As this goes into future, the yellow represents anticipated growth. Very clumsy, very basic, very regional, not done at the parcel level at all. We can jump to another one here in Yavapai County, Arizona, where we have an enormous growth rate, that 4% there. This is the Verde Valley south of Sedona. 50,000 people live there. This growth rate out to 2050 would bring 250,000 people, in addition to the 50,000 living there. The only land available for development is shown in colors. All the rest of the land is state, federal, or tribal land. Even this triangular piece of land here is state trust land, which we've assumed for modeling purposes is available for development. You'll see the allocation to land use types over here. Now, running the first scenario, 4% population growth rate out to 2050 means we've got to go find those circles and take that land down from the national forest or public lands to develop it. We have run out of land in the existing model. We cannot tolerate another 250,000 people. This does not visually portray what's happened to the quality of life if you fully develop all of this. And that's what the public groups with whom we met said, oh my God, you put 250,000 people on top of us, I don't even want to live here anymore. Good. we've now achieved managed unattractiveness, which is a goal that some communities have. I think it was Jackson, Wyoming, or Jackson Hole that quit filling their potholes in, and people said, this is terrible. I hate to live here. Look at these streets. Wonderful. I think City Council has since been replaced, and there's a lot of sprawl outside Jackson Hole now. You can change the variables here with the densities on the right and begin to fit more people in. You can keep doing that and keep clustering it. This one, however, has a miracle occur. See up here where we stop from 4% and go to 1%? This public group said, let's presume, because 4% growth is going to kill us. It's going to be a rotten place to live. Let's presume that some public policy reduces growth to 1%. And we have this kind of scenario. We love it. We can live with that. That's good. How that miracle happens and how you reduce growth and manage it down to 1% is quite another matter. That's one of the advantages of dealing so far out in the future. Miracles can occur in the variables, and you make assumptions that do that sort of thing. This then is more tightly clustered growth and everything fit. You can run this at the parcel level. That was the regional level. This is the parcel level. This is Oak Creek Village just south of Sedona. And we just kept tightening up density here until we had a pedestrian community. So the model is very scalable that way. And what you've seen now is how we technically accommodate different opinions and values. We have not resolved a conflict or helped them develop a course of action. We've simply shown where different densities would take them with fixed population growth rates, or if you vary the population growth rates, how it would go. This is a case study. We didn't do it as a case study. We did it as a real project, but I present it here as a case study. The issue here is starter castles. These things showing up on 40-acre parcels and losing the big sky feel in Montana. Scares them to death up there. And this was really during the 90s when there was a lot of dot-com money coming out of the east and into the west. This has slowed somewhat, but the issue here is one of private property rights. This guy gets a building permit, builds that house. He's got a fantastic view. He does everything legal. Well, so do his neighbors. There goes the view. And therein lies the problem, which I think is, we touched on it this morning. Let me segue to it now. Let's see, what did I do that you're snickering back there? I can replay that for you and send it to you. You'll have it. But the problem is, the biggest problem I think threatens civilization is that we value the individual short-term good over the long-term collective good. And I don't know how to resolve that. That's really a theological problem. And we don't know how to go there. And the best hope I would have for that is that by some conflict resolution process, we can begin to show people the wisdom, the value, and we need a dose of economics in here as well, of respecting the long-term common good, lest we shoot ourselves in the same foot with both bullets. What we did here was a current trends for this area. It showed growth looking like that. They didn't like that a bit. We met with the ranchers. They said, okay, you can develop all this land in blue. We met with the environmentalists. They said, well, we're going to save some steep slopes and riparian areas. Developers said, you can take this blue land out. So they each gave us a land bank. They don't use the word zoning up there. They never use the word zoning. And we were advised not to use it lest we go out horizontally and in a box. And so we called them suitability rules. It's zoning. You read any one of those and it's zoning. Each group had their own set of rules. The interesting thing here was when we portrayed the results, and we did this to a packed house of 250 people at Museum of the Rockies with 250 people standing outside waiting to come in for a second showing. The ranchers wanted clustered development around existing community centers. so did the environmentalists, so did the developers. My gosh, what was the difference here? When we ran this thing out 50 years, they really all wanted to preserve that open space, to have cluster development, and their values were the same. The thing they agreed on wholeheartedly is, my God, we do not want to go where we're headed. This is just another little visual, and I'll let that play forward. Gary Fram at the Cape Cod Commission had done this, and I'll follow this with a sequence of growth that we had out beyond this. That's their current build out. We made some baseline assumptions and did a model run for them. Based on what we did, they need to start a development out in the bay of about that size to accommodate new growth. It seemed quite all right with the residents with whom we talked to put newcomers out there. They were very, they thought that was the right place for them. We can revise that growth scenario and then just step through some different alternative land use things. Short-term impacts, I'm not going to take the time to dwell on the model for that much, but this really deals with episodic events, whatever it may be, those sorts of things. An interesting thing to note here, particularly because of your interest in conflict resolution and the human side of things, is how emergency managers look at things and how planners look at things, and the difference in how they do. Why don't they work better together? They use the same technologies, the same maps. They need to know the same addresses, the same data sets. It's, in my opinion, and I used to be a fire chief, and I never pulled up in front of a house on fire where people wanted to have a meeting. They wanted you to jump out of those trucks and take care of that fire and do not talk to me. They are screaming, put the fire out, my children in there, my dog's in there, save my stereo, I got a 12-pack in there. A planner can't do that. A planner has got to have meetings. They've got to work with the community. So the decision processes are different. And getting these people to work together is usually a very serious objective that we have with every community for its own good, for its own cost effectiveness, safety, and so forth. This is maybe an editorial comment, but we will fight. We will fight and kill for the right to do this. And if you've worked with planning jurisdictions and so forth, it happens on both coasts. We deal with fire much the same way. It's very complex to deal with fire, and it takes a lot of agencies when you get a big fire. We work with fire at home. This is the flammable fuels around Prescott. Prescott's burned down twice, so we have an ingrained aversion to fire. This is a model we did of, in working with all those agencies, they wanted a training session, so we lit a model fire for them that burned like that, ran it over. That was a 4-day fire. We compressed it into an 8-hour shift, and they dispersed resources and did everything in their training process for that. 6 months later, that's where the next fire started. We had nothing to this was a controlled burn in New Mexico. You read about several years ago. But people will build a shake roof house in a national forest. They won't build this metal roof house, which is still probably pretty safe. That could possibly be saved, particularly if they've cleared a little buffer around it. But they'll build that, and then they'll want taxpayers to come in and suppress that fire, and they don't want fires at any cost. So it's interesting. When people want to be regulated and affiliated with the government or de-affiliated with them so they can go do this and then call the government to bring all the resources in and take care of that fire, which becomes tragically personal in all too many cases. The event model does just that, builds that perfect hurricane across the island of Maui. That could be a fire, could be a terrorist event, could be anything. We initially built a model for a hurricane, and it picks out the parcels underneath it simply by piercing through different GIS layers that are subject to the highest wind speed. It then prints out where the property losses are based on the values, the tax-assessed values per parcel. Now, you can run this over a current land use scenario, or you can do a future land use growth and run that over it also. It doesn't matter. This little community of Kihei, we compressed a lot of information in this. The red roof structures are new. The year is 2030. The red roofs have been built since the brown roofs, which are there now. You're looking at a 10-foot storm surge that has overwashed from the right where the ocean is. You're seeing right here the evacuation route underwater. That evacuation route, I think that is 6 feet underwater at present with the water level of this surge. But at any rate, this was very helpful to them in deciding to build an upcountry connector out of this area so they could get out, and also in looking at some of their building codes and zoning policies. This particular AVI dives underwater, and folks always want to know, where are the fish? Someone who's been in a flood before will say, that's the cleanest flood water I've ever seen. But this particular methodology, going 3D and running and flying through that, is a way to portray or convey a lot of information in a very brief time period. Because if you live here and that's your house, and we'd pause this so you know it, you know the neighborhood, you know where you are, and you begin to understand pretty quickly why public process is really tending to deny you a building permit, or saying, if you build here, we want you to harden your home and build a breakaway ground floor, or take other measures to protect that investment. We interface with very complex models, and this is one, Larry, I think you were mentioning earlier. We do not do tsunami modeling. They do this on Cray computers. But it may be a very good way to say to someone, I'm sorry, we're not going to let you develop up in that cove. It's just too risky. We're a tsunami-prone area. We're not going to do it. This is a wonderful place to play. I'm changing topics on you a little bit here. But in the event of a terrorist event here, this is not a good place to be. And all of a sudden we find that tourists, which are the core of the economy there, have shifted from the asset to the liability column. Interesting. I'm not going to dwell on that point. I'm going to jump to long-term impact models, which does just that. We do water modeling. We are not hydrologists, so we don't fill in the data tables here. We let others do that. But this is where we interface with climate change and recharge and precip scenarios. There will be as many different opinions on hydrology as there are experts called forth to testify. And we built a model here that can do a model run for any given set of opinions or assumptions. That lets us just say, you know, we don't know. We have a model that will accommodate everybody's opinion, and we defer to the decision makers. Again, what we've done is not resolved conflict, which in our case, in Yavapai County's case, because we are water critical, the conflict has been avoided. It's not discussed, it's talked about, it's studied, but it's not dealt with in a forthright way. There are different ways to visualize this. This is the sustainability indicators simply tied to land use by land use type and resources consumed by a particular land use type. You can change the land use, and that will change the size of the footprint, as you see here. This has probably gone up. Embedded in this is a social justice question. And in a public setting, a public meeting, or before a board of commissioners or a city council, we never raise it. But who is entitled to what resources around the planet? Right now, we'd need 2.5 to 3 additional planets for everybody to live at the same standard of living we live.
Well, before you go on there, why is pasture land, footprint land for the people living in those units? Why isn't the footprint land in another county or in another country?
It is.
So when you go back to the previous map, how can you allocate the footprint within that place without assuming a direct connection in propinquity with the people living in the place?
We do that probably poorly because we've not spent much money on this. We do that by saying for the amount of beef they consume, they need this much pasture land. This is not a researched number. This is just a national average. And we get the land required wherever that productive land may be. And it's an excellent point. I left out the term, the amount of productive land required to support. And it doesn't matter where that land is. Energy is managed by the amount of productive forest to sequester the carbon produced by the method of transportation use.
Can you go down the list? Just say that assumption for each of those. To get it, this is to get it footprint.
Yes.
This is how you convert certain needs or requirements to land.
That's right.
So could you just take us through that?
This is the kilowatt hours used for the density of the land. Now that may be multifamily, maybe single family, maybe commercial business. So that's going to change. But the acreage over here is represented by the amount of forest land to sequester the CO2 produced by the energy used. So if this is PV energy, this number is going to go way down. If it's wood-fired, it's going to go way down. I won't go through all of these, but food consumption is probably duplicated or, again, referenced in these two. Let me back up one slide and see what we had up here. This one is for a single piece of land, and looks like 400 acres with 4 dwelling units on it, and so forth. But the tables that support the amount of land required to sustain this activity, whether it's a family, a business, a community, a state, a nation, a planet, are represented in the tables. They are arguable, and when we've discussed this with potential clients, we've told them, look, we would have a very difficult time coming up with an actual number here that we could support. Tough to do, but we can put a number out, use the same methodology, and you can use that as a benchmark against which you can gauge progress towards sustainability or competitiveness. And depending on the audience with which you're visiting, you may want to use competitiveness instead of sustainability. Anything that reduces the throughput of resources lowers your waste stream, for which you're held accountable, and your costs as well. So there's quite an advantage to that. Why bother with model-based planning? For our purposes here, it's the only way to interface with the science community. There is no better way to incorporate science into the planning process than through models. It's going to be cheaper. If your clock speed of change is fast, that doesn't necessarily mean you're growing fast. You may be losing population, or your economic base may be shifting. But if things are changing fast, this is a way to plug changes in, look at them, evaluate the consequences if you've got high risks to these minor decisions. And the risks we've got today are huge compared to the risks attendant land use decisions, say 100, 150 years ago. Little decisions can impact a lot of people for a long period of time today. If you need feedback and you'd like to know where this policy change or land use decision may take you, this is a very good tool. Being able to evaluate consequences and look at those different scenarios and say, At that point, then, we defer to you for helping people resolve the conflicts and coming up with an action plan to achieve a desired or compromised future. And that's where I think we have a lot of interesting ground to plow. The capability, our technical capability, probably exceeds our process capability today. And we talked this morning, and by the way, those of you who were with us this morning deserve a special award for sitting through this twice, because we did get into some of these issues this morning. But our technical capability today really exceeds our process capability, in my opinion. This is a picture of Earth from a satellite we launched in 1800. This is labeled, by the way. And that's what you would have seen in 1800. You know what's coming next is that one. And where are we going with this? Where are we going with this? I made an op-ed statement this morning that we're not really at risk now to losing, let's say, an Aztec or Mayan civilization down there and Anasazi civilization here. We're kind of all in this together now. And when we realized the Nikkei tanks and the next morning the Dow tanks, we're linked economically, socially, culturally, politically, militarily. We're linked in ways we don't like. We're linked in some ways that are very helpful. A disease can show up over here and be in New York City within hours. The risks to humanity are enormous today. This is a fantastic time to be alive. This was a quote from someone who used to work at the White House OSTP. And I just always kind of remembered that. I think this is one of our challenges, is to really better use the technology. To do that, we're going to have better process to accomplish it. And we're going to have process that helps us resolve conflicts. We can portray future scenarios forever. And we leapfrog, when we do that, we leapfrog the real issue of how do you get there? How do you resolve the problem steps and implement the policies that get us there? This is in working with a student audience, I really encourage abnormality. And for those of you who teach, I think we really need some unusual people to do some absolutely off-the-wall, seemingly insane things. I try, but my IQ's too low. We need some really brilliant people to get out there, and we need them badly. We need them now. And I would hope through the program here and the work we do that we can help contribute to that. I had an interesting discussion with Alicia on the phone about the environment, and she asked if I'd talk about it, and I declined. I said, I don't think the environment's in trouble. I think really the difficulty is with ourselves. Earth has healed itself and re-healed, and we've had extinctions and meteor impacts and on. And in my opinion, the Earth is extraordinarily resilient and will bounce back in one way or another. Whether we'll be here in this form or not, or in a discussion with my brother yesterday, We discussed philosophy by telephone. I think I used the phrase, I think we're ripe for the next species, I would call it Homo follow-onus, to emerge, who deal more wisely with the issues we have. And with that, I thank you very much, and I hope I've not transgressed my, my time.
Give us a sense of what, taking the templates for the modeling for a place like Valley or Cape Cod and getting the data set organized and producing the visual picture of the 50 years growth costs?
The contract we have for Maui right now is $207,000. That includes a spatial growth model, an upgrade from ArcView 3.2 to halfway toward running on ArcView 8/9. It includes a long-term water impact model for water availability. It includes a transportation model for the impacts of various patterns of growth on their transportation infrastructure, and that includes a storm loss assessment module.
For that client to get that model at about $200,000, what do they have to invest to collect the data to put into the model so that you can do the modeling? Do they have it all from existing sources, they just don't know it, or do they really have to generate the data from scratch?
In most cases, they have it. In Maui County, they're probably data rich.
And it comes from normal things that they've been doing all along? Or
Yes.
that you can get from Landsat, or you can get from the census, or you can get from existing places?
They have aerial photography, and they have parcel maps. We overlay those two on a digital elevation model, which they have. And probably in some cases, we will have to degrade a high-resolution aerial photograph just to get it down to a file size that we can process and fly for 3D. We did that with that Kihei community. We had that at very high resolution, and we degraded it so you didn't really see the street edges very crisply. They were in the right place, the buildings were in the right parcels, the parcels were in the right place, and so forth.
So that they have the data, you don't have to spend large amounts of money to get it. For a couple $100,000, they have a capacity to take groups of people through the process of visualizing what different scenarios are likely to get them. You know?
Yes.
Just summarizing, I'm just trying to get a sense of the scale of investment for doing this. I mean, in the past, to make even simple land use models, we're talking about millions of dollars invested over a decade. Some of the ones that we know from the East Coast that were the Penn, Jersey, and all the others that were designed just to make a forecasting model without any visualization. So the question now is, if something is at this price with existing software off the shelf, you don't need to have someone constantly coming from outside to maintain it once you've done it once. Presumably you can upgrade it and update it.
We'll complete the Maui project with an install and training session. And Bill Medeiros is their GIS manager there, and we've worked with him for 3 or 4 years. He can already run the model.
I think this has been great, and the level of detail that and impacts that you guys are measuring is pretty amazing. I'm wondering, and you said it yourself, the implementation is the challenge. I'm wondering, mostly, it's a 3-part question, sorry, but who are the clients? They sound like counties and regional agencies.
Cities, counties, and regional planning organizations.
And then in terms of the implementation, I mean, I really think that's where the investment comes in terms of time, money, and political will. What have you seen, or with your projects, like where has this been taken to the next step, the implementation step? And as a NASA-funded center with federal money, what can you or the federal government do to implement this change at the regional and local level?
NASA's pretty much out of the picture. They have focused their energies on shuttle return to flight, the International Space Station, colonizing the Moon and Mars. I have yet to stand in front of a city council or a board of county commissioners that had a problem on the space station, on the Moon, or Mars. So NASA is back to just scientists talking to science. They have right now no policy intention to bridge to Main Street and make their information of value. And what was the gist of your question? Pardon that op-ed piece there.
Like I think the biggest challenge is getting cities or counties to work together, and they need some sort of impetus or someone with more power to push them in that direction. I mean, I think that the data and the information you have is a big part of that. But who's going to push from or where's another push going to come for them to start working together and actually making good use of all this?
It's usually done, in our experience, with perceived self-interest. And that's why a lot of our work is done at the regional level, and where one community realizes, for instance, within the Tampa Bay regional area, Tampa per se can't move much without the other communities in the other counties, because they share water, they share traffic, they share economies, they share storms. They're so intertwined already that their issues cross jurisdictions. So we generally end up working at the regional level because smaller jurisdictions within that boundary realize they are not going to fix that problem or address that issue themselves. They have to work with the others.
Well, this is kind of follow on to that. One of the things that's, first, thank you. It was really fascinating to see it, and I know the amount of work that goes into them. They flow by so quickly, and how painstaking it is to actually make that happen. But are there? You talked about. I think you said regional planning organizations, counties, and towns. But we know now that in a lot of ways, these sort of government-centered efforts aren't really where change happens. And in fact, it's the creation of networks, is usually the way it's referred to, of actors across lines that often is what creates change. And are there instances where engaging in this kind of modeling and the kind of reflection it prompts, where you've ever seen a network of actors coalesce and that are committed to take at least some provisional steps? Is there,
yes, in the case of Gallatin County, where we brought the ranchers, environmentalists, and developers, we met with them separately. After we left, they joined together and they passed a bond issue for $10 million, which was a pretty good chunk of money for Gallatin County to purchase open space, transferable development rights, and some of the ranch land.
So do you think that meeting with them individually or something, as opposed to a town sort of contracting for this general comprehensive plan, and then the other actors kind of seeing some, maybe things that they don't want to know, but probably intuitively had a sense of the implications of their, accumulated actions, as opposed to contracting for some kind of analysis that's fairly focused, given the kind of more modest scope of finance that Larry was talking about. And so the analysis actually becomes a way for them to start to identify joint actions that they want to take together. So that's the trick, right?
You've asked a complex question. We deal broadly with issues. So if we go in and let's say the issue is water.
Can I give an example? You realize it was, are there any example where you might have had, instead of the county doing it, like on Cape Cod, a the Developers Association is worried because they're going to kill the goose that's laying the golden egg. There's some conservation groups that are interested, and then there's 5 towns planners are interested, and they as a group contract to have some kind of modeling done. It's very much more specific, but that leads them to actually act. So where this leads to act, commitment and action.
We only contract with
Okay.
jurisdictions
Yeah.
and political
Okay.
entities. But the action taken in Gallatin County where they passed the bond issue, I can't say that resulted from our action alone. We were part of a larger concern there, and we were brought in to be catalytic. Larry, that job in Gallatin, to address 2 of your questions, only cost 30 thou. We made 2 trips there. They did not have squat for data. I think they had population data for the county, and we just brought down Landsat, USGS, DEM to put under it, and built a model, and then we flew through the model. But it was done at a very low resolution, and we had to supply a lot of the data.
Back to the technical side, you said that you were doing disaster vulnerability mapping.
Yes.
I was curious, are you focusing just on built environment, or are you able to do some layers with some of the socioeconomic data, and if so, what have you seen?
So far, we've focused only on the built environment. It would be fascinating to focus on the socioeconomic aspects of a disaster, and kind of the comment within the disaster community that if you don't get a small business up and running in 30 to 60 days post-disaster, you've lost that small business. And pulling that aspect into it mechanically, technically, be pretty straightforward. Getting the relationships right to input into the model would be more difficult, and would probably lead you to say, I want to test 4 or 5 different basic relationships here. And they would differ by place.
Yeah, I was going to say, including, not just the small businesses, but the household incomes, things like that.
Yes.
Because I think there's a lot of questions in terms of what's happening with resilience or rebuilding in certain communities.
Yes.
I guess I was sort of surprised to hear that people aren't very interested in that spreadsheet that lies behind the modeling you're doing, that you said that people don't usually want to see that data. I guess I could envision a lot of communities where there was more conflict maybe, or I don't know if the situation was different, where that wouldn't be true, and they'd want to know how you're making these lovely and very interesting pictures. And I would think that maybe goes to that bridge you talked about between the science and the decision makers or the stakeholders. And I guess I'm interested in knowing more what you think about that bridge, like who is that bridge and what's the vehicle for that bridge. So if people do start asking more questions, how you bring together putting together the model and the data behind it, the science, with the people who are living in those communities.
Well, thus far in the work we've done, we have been the bridge. And I can only remember one public meeting where someone said, "Where did you get that?" And Hoyt, my companion, had the spreadsheet, and he called it up and said, "It's right there."
And the spreadsheet's enough, they don't need to know who collected it or anything like that?
No, there were no questions beyond that. It was a spreadsheet based on.
Totally disagree with the data.
Right, yeah.
Well, that spreadsheet was based on historical population growth for the Dewey-Humboldt area where we live, and it was not logarithmic, but neither was it linear. It was growing rapidly. I'm on the wrong side of the slope here from where you're standing. It should be growing that way. And so we simply did a best fit match with future value of a given sum of money.
I have no idea. I'm from Gallatin, and I'm like, where did that come from?
Gallatin was a fixed,
Well, maybe that's a bad example.
and the matrix that I showed for Gallatin, the planning department had. Now, whether they did that or got that from a consultant, I don't know. But once we show people, and particularly in the area of Dewey-Humboldt, where they had no projection for that area, we used the historical run, and then we did a high, medium, low, and I think we did a flat. That took care of it.
Yeah, I think the problem for us, and I'm trying to think about ways of interacting with this kind of set of tools. The problem for us is that the numbers don't equal science. That science is something else. And so the question is how to use the tools which present the numbers to, in fact, make explicit the scientific judgments that lie behind the numbers, and to, in fact, think about visualization tools, another generation of them that may cost more to create, that, in a sense, bracket the scientific debates and force those scientific assumptions and the debates around them out into the conversation in the community. So, for example, if we go back to vulnerability, if you were to run something that showed vulnerable areas in blue from the standpoint of land use and natural features, and you say, these are the most vulnerable areas, they're all in blue. You say, great, your model shows that. You say, now, if you want to define vulnerability in socioeconomic terms, these are the areas, they're all red. Oh, different areas are most vulnerable depending on how you decide to define vulnerability. And then up would flash the two sets of assumptions, the arguments for and against defining vulnerability one way versus the other, and it would force that question and that choice, if you will, or the balance between them, back out into the audience. Instead of allowing the audience to defer, it would throw those bracketed considerations in their face and require them to confront the fact that you'll get a totally different picture depending on where you are within the bracketed debate. And you could do that even with just, natural areas or with natural phenomenon like water, right? We could just take the water and we would say, what are the wetlands? Where are the wetlands? Well, that depends on how you want to define a wetland. Some scientists, and then the thing comes up, some scientists define wetland with these three considerations. Others define them that way, looking at historical wetlands, even if they're not wet now, folks. And the map first shows you the one, then shows you the other, then shows you the overlap, and says, as far as protecting wetlands in our community, we're going to have to decide whether to use the A definition or the B. Here are the scientific arguments for and against A. Here they are for B. What do you want to do about wetland protection, folks? And so it would force this out.
That's interesting. Now, there's one thing we do that you've not seen here, and it's in our public presentations, we customarily use 3 computers, 3 projectors, and do it 3 screens wide. So when we did Gallatin, we had those 3 desired future scenarios all up there at the same time. And when we had placed the 3rd one on screen, we call these just round balls. We put one on the left screen, and the other 2 were just balled out. And so we progressively then put the other 2 up, and then just stood and let the audience think about that for a minute. Now, that would have been the time, maybe, for someone within your discipline to have come on stage, or if we had the skill to say, okay, you've got 3 different things here. They're basically the same. The next 3 slides are going to show you steps that you can take to get there and force some decisions or some process.
No, it's not. Well, I see why you're saying that, but I'm less interested in the steps, because even the steps bury the assumptions. What I want to do is bring out the arguments for and against the different assumptions that would lead you to different steps or different pathways.
Okay, then would you go back to the then you'd maybe want to go back to the zoning rules, the suitability rules that we had,
and I want to
say, okay, here's the
rule. If I change this is kind of sensitivity analysis. If I change the rule this way, and here are the arguments for and against changing the rule here's what scientists say are the strengths and weaknesses of using this rule.
Okay.
Here's what they say over here. So it means adding a kind of dialogic overlay to all the imagery and knowing where to bring out the bracketed assumptions and have them be visible to go with the mouse. That's the thing that we need to think about software that can help us do it. It's great to have these images. I would love to have them, and then we try to overlay on it this other. And so as we think about possible collaboration, what I want to do is think about ways we could piggyback on these tools to force a different dialogue to happen in the community. I don't want anybody accepting the underlying data where there were scientific or political judgments that could have changed dramatically what the model shows you without questioning those, without being confronted by those. That would be the connection between the two.
Well, specifically with that Gallatin case, you guys didn't know how many slides you looked at today, did you? It was just about 200 slides is what it was. I wouldn't dare tell you that ahead of time. But if we went to Gallatin and we looked at these three and we tried to pull commonality out of these, that might begin to get to your point, and then we would be able to show these and say, okay, here are the commonalities among your assumption sets.
No, but even underneath that, when you say not on prime ag land, okay, let's show what the prime ag land is, and then let's say what is the likelihood that people in this area will need that agricultural land for their food production? What is the likelihood that other people elsewhere in the United States will need that? To what extent will it not be needed, but might be desirable from a standpoint of international trade? I mean, why are we protecting ag land? What are the arguments for and against protecting what we have now in agricultural land? You say, because it's prime ag land, let's protect it. Why? What are the consequences of protecting it or not? For whom? And then if we bring those out, someone says, well, okay, let's what if we gave up 10% of that in order to have affordable housing? Okay, here's what that would look like.
Yeah.
Okay. So it would build, if you want to get these, I think you have to get these out. But then you want to get underneath it, what are the assumptions you make about why you do this? What do scientists from different disciplines say about for and against doing that? We're at time people have to go to class, so, well, thank you so much. Appreciate it.
Thank you very much.